Quantum computers are considered to be the next big thing in the computing industry. The massive chandelier like machines are known to use many principles of quantum physics to help solve problems that would originally take a classical computer millions of years in just a matter of seconds. So, how does a quantum computer do that? Let's get into the subject bit by bit. Let's first understand how a classical computer works and interprets data. Classical computers interpret data in the form of bits, and a bit can be 0 and 1 by a switch like device called a transistor. When a transistor is on, it represents the bit 1, and when switched off, it represents the bit 0. However, when you come to a quantum computer, a bit can be 1 or 0, or both at the same time, and these have a special name which is qubits or quantum bits. An interesting way to understand this phenomenon of being in both yes and no states at the same time is by taking an example. Imagine your friend gives you a pizza and asks you whether you like it or not. If you were a classical computer, your reply would either be yes or no. But if you were a quantum computer, your reply would either be yes, no, or kinda. This property is called quantum superposition. Superposition is the ability of a quantum system to be in multiple states at the same time until it is measured. So, how does that translate in the real world? Well, what a transistor is to a classical computer's on and off, photons, protons, and electrons are to a quantum computer's qubits. An electron has an intrinsic property called spin, which means that it will have a mini magnetic field of its own, which makes the electron act a bit like a compass needle. So when an electron is put in a magnetic field, the electron will align itself in the same direction of the field. Now the electron is in spin down position, and when energy is applied to the electron, it is in spin up position. With the help of superposition, the electron can easily switch between these two states, as superposition allows the electron to be in both states at the same time. It shows that qubits are far more flexible than bits. An application of this flexible nature of qubits can be decrypting passwords. Let's say we have a computer we need to decrypt. Here is a list of all the possible passwords of the computer in the form of bits. Imagine trying to input all these passwords one by one the way a classical computer would do. For a simple 4-digit pin like this, there are 10,000 possible combinations. However, if a quantum computer were to do this, it would only have to input 4 qubits, which could easily try all the possible values at the same time and crack the code. Thank you for watching this video. I hope it helped you understand a little bit more about quantum computing. If yes, that's great. If not, that's okay. And if kinda, well, that's quantum computing.